Good morning, everyone. Brian here. It's about 4:30 a.m., just after actually here in Florida. I've been up for about the past 2 hours thinking about this. My mind is racing with this new idea about moonlight and possible capacitance of the moon. Is capacitance a word? I don't know, but I think it is. But yeah, my mind is racing. I'm just gonna have to go until I faceplant because I can't stop thinking about this. It's too amazing. People have made great comments both on Facebook and YouTube about this topic. Awesome suggestions. What I want to talk about is the cynic made a comment on YouTube about deserts and temperature swing. And how in the desert in the daytime it just gets very hot, well over 100 degrees Fahrenheit, and then at night it gets very, very cold, like down to freezing temperatures. And I was thinking about why that is, and I remember and the reason's got to be because there's no moisture, there's no water out there, because water holds heat very well. Is another thing my dad ingrained in my head as a kid is that's why you see fog above ponds when the air temperature drops very quickly, because the water retains the heat that it had. And if you live near the coast, in the springtime it takes a while for the water to get warm as you get into the summer months, and then as you go into the fall months, when the air starts to get cold, the water's still warm because it holds onto the heat. So it also takes longer for water to heat up. Water is a very good insulator, so to say. And so I was thinking about this, and somebody else posted under, I can't remember who it was, made a comment about heat escaping from the desert. Is it really black body radiation going out into space? And I was thinking about that. Well, yeah, because the heat's got to go somewhere, right? Where's the heat going? Really, it's got to go somewhere. It can't just go out to colder areas of Earth, because they're also cooling down too. So it's got to go up into space. That's what I've always thought. But then I realized, thinking about this, laying in bed, well, there's kind of a problem that there's a thermosphere in the way that's about, I don't know, at least 400 kilometers thick, with very high temperatures. That's an issue there. Do you agree? How's the heat going to radiate up from the desert through this? How it goes to cold? Definitely not. We're kind of insulated against space at that point. That's what holds heat into Earth. So where's the heat going? It's got to go somewhere. I don't know. A little more evidence. Still, we need to prove this. But another thing I was thinking about is, what is a capacitor? What is it? And also, Ank, backing up, Ank came in again. Anky, you got to tell me how to say your name, but with another great point about capacitors. And I had to look this up. I had to wake up and look this up too. Apparently, capacitors, they don't charge evenly. The rate of charge and discharge varies, and that's exactly what the moon phases do. He pointed out that if you look at a moon calendar, he actually posted a link in the comment to the moon calendar, which is so interesting. When the light first starts to appear, as you get that little sliver as you're heading towards the waxing crescent or the waning, I get them mixed up, but it's basically you get like 1% of light, and then 5%, and then 12%. This is going up in consecutive days. It's not a uniform linear is the word I'm looking for. Opening of the light, or the light appearing on the moon. It kind of jumps up and then jumps down. It's like it's almost maybe exponential. I'd have to look at it more, but it's not linear, and supposedly that's what capacitors do too. So this is really interesting. But I got my circuits book out, basic circuits book. I held on to this one too, just to read the definition of a capacitor. It says, a capacitor is a circuit element that consists of two conducting surfaces separated by a non-conducting or dielectric material. A simplified capacitor and its electrical, now it's just describing the figure, but there are many types of capacitors, and they're all categorized by type of dielectric material used between the conducting plates. So what I'm thinking about is what are the sun and the moon the plates, and then there's some kind of dielectric material between them, or is the moon the dielectric material? This is just something to think about. It's basically like an insulated material, something that doesn't conduct. And so just throwing that idea out there, get more people thinking, because as I've said before, we're all working together here. So many people have good ideas, and I can be the guinea pig on camera, just reading all these ideas, trying to put them together, and then throwing them back out there, and getting more people's input on this, and we can keep going and charging towards truth with all this stuff. And on Facebook, I think Stefan Ludwig made a comment about lenses with Moonlight. You know, when with sunlight, you can take a magnifying glass and you know, you can set a piece of paper on fire if you focus the sunlight. I used to do this when I was a kid. I think every kid has done this. You know, kids burn ants and stuff. You know, boys just doing mischievous things. I don't think I ever burned ants though. But so what happens if you do that with Moonlight? Has anybody ever tried that? And immediately I thought, well, what if you did that on a candle flame? So I tried to draw this as a really crappy lens. This could be a magnifying glass or some type of lens. What if you know, I guess if the light is actually traveling up, if it's pulling light away from the flame, I mean, really we can't see which way the light's moving because it moves too fast. But you're still focusing the light. Would it actually intensify the flame? Is this the way we could actually see the flame intensify over another flame that's covered from moonlight? Or even if they're both exposed to moonlight and you use a lens on one, this is another thing I really want to try. I'm going to have to get a good magnifying glass to do this. And I think there was another point I wanted to make. So many thoughts. I could probably ramble for hours in front of the camera here, but I don't want to waste too much of everybody's time. What was the other thing? Oh yeah, I want to point out that we're not measuring the temperature of the light. I said that in the first episode because I was too excited. I mean, it is semantics, but we're measuring the temperature of the air. Just like, you know, I explained in the Balls Up Physics episode 4, is the thermometer measures the kinetic energy of the substance. So we can't directly measure the temperature of the light. So just keep that in mind. I'll probably say that again when I'm talking quickly. We're measuring the temperature of the air, so the moonlight is actually cooling down the air as opposed to the sun. You know, it's definitely true that if you measure the temperature of air in direct sunlight, it's gonna be warmer than the temperature of air in the shade. So what we're looking for is it the exact opposite with moonlight. And so I've also been looking at FLIR infrared cameras too, because I really want to do this right, and there's some deals out there on Amazon. So if anybody's got one of those and they want to use this and try to position it on a line between moonlight and shade and just record the results somehow, that would be great. Because the more we can show the moonlight cools the air or cools whatever it's shining on, the better. And then one more. Somebody else made a comment about how clouds look around the moon, you know, and sometimes you see those really cloudy nights. It looks like sometimes it looks like the moon, there's like a hole in the clouds, you know, like I see this a lot. I mean, especially since I've been studying flat earth theory, I've been watching the moon on cloudy nights, and people talk about how it looks like clouds go behind the moon. Well, what if it's absorbing energy from the clouds? You know, H2O, I mean, clouds are basically water. There's a lot of energy in hydrogen. You know, H2 gas, hydrogen gas, there's an extreme amount of energy. I mean, that's what happened to the Hindenburg. You know, it's filled with hydrogen and blew up. That's why we fill pumps with helium now. And so, you know, these are things to think about. I'm speculating, yes, of course. I mean, basically I'm saying the moon is eating clouds, so I mean that's out there. But it's just things to think about. More ideas to throw out there. The more ideas we can get together and keep working together and charging towards truth. I keep saying that, it's getting corny, but yeah, just want to record some ideas. I can't sleep, so hopefully I can fall asleep sometime this weekend. But I hope everyone out there is having a good time with this, has as much fun as I am. So I'll talk to everybody soon. All right, peace.